ability to access information, and we can overload our system with too much, and we can't impede learning. But another thing is using the ICAP theory, which is that interactive, talking with somebody else, turn taking, discussing, leads to more learning than constructive, where you create something new, which is more learning than active, which is physically moving something or doing something, versus passive, which is often a standard lecture. So the things that I tend to work on are being, having students be more active in, I don't do a lot of lecture in lecture. Let's see to the next one. So one of the things I have been doing is creating free and interactive ebooks for learning, so that apply educational psychology principles. So one of the things from cognitive load is worked examples plus practice is better than just making people practice by itself. So having an expert solution to a problem that you then get them to do some looking at to understand what's happening there. So here in this case, we have a turtle graphics Python example, and then we ask questions about that example to get them to pay attention to things. We also do something called Parsons Problems, or mixed up code problems, that I'm going to talk more about. I also do process-oriented guided inquiry learning, where you have students work in groups to analyze a model and answer questions about it. And in this case, that model is often a program. And then one of the things that we have the most evidence for improving student learning and motivation is peer instruction. That's asking a hard multiple choice question. If you are lecturing, stopping at least every 10, 15 minutes in the lecture to ask a hard multiple choice question, have students answer individually, turn and discuss with peers, the people around them, and then answer again. And so we have decades of evidence of this. It originated in physics at Harvard, but it's also been shown to work in computer science. So the ebook platform, it's a free and open source ebook platform I work on. The founder was Brad Miller, who created first one interactive ebook based on how to think like a computer scientist in Python years ago, back in 2011. Now we have over 90 free ebooks for computing and math. There's CS1, CS2, Python, Java, C++. We have an average of 2 million page views a week. I created 2 of these free ebooks. So CS Awesome and CS Awesome 2 are for what's called Advanced Placement Computer Science A, which is an object-oriented programming in Java course. And then it's a CS1. And then I teach also from a colleague of mine, Dr. Chuck Severance, created this Python for Everybody book and Coursera course, very popular. But I made it interactive because his book was static. So there's a list of free ebooks here on the Runestone platform if you're interested. So one of the things that I've done a lot of work on is Parsons Problems, which is asking people to write code from scratch can be too much cognitive load and actually impede learning. And so one of the ways that you reduce the cognitive load is by doing a partially complete problem. And so what you do in this case is you generate the correct code to solve a problem, and you break it into blocks, and then you ask students to put the blocks in order. And with Python, that includes both the vertical order as well as the indentation, because Python requires indentation. And you may notice these pairs of correct and incorrect blocks on the left that say like 1A, 1B. Those are pairs of things that are correct or incorrect to get people to pay attention to, like, you need the parentheses or you need the colon. So this is one of the things that I and my students have been researching for over 10 years now. And one of the things that I did was I added a bunch of Parsons Problems to a free ebook, and I then looked at the log file, and I found that some students really struggle to solve them. And practice isn't helpful for learning if you're never successful. So one of the things I did was add a help me button to help students get to a correct answer. So if the learner is struggling, they can ask after they've done at least 3 incorrect full attempts, then they can use the help button to remove distractors or combine blocks. So I'm going to show you this live. So here's one of the books. This is the Python for Everybody book that I've also added other material to, like turtle graphics material. Actually, you can go back to the original one. So here's that example of a turtle. You could change the code if you want to see what that does, which is kind of handy for students. They don't have to type it in. They can just play with it. So they can think about what this is doing. There's that question to ask, which way is it created when it's which way is it facing when it's first created? And of course, it starts going forward that way, so it should be to the east, but you get immediate feedback if you're wrong, if you answered north. If you answer east, you find out you're correct. And then this is the Parsons problem or mixed up code problem, where I'm giving you now is similar to that worked example, similar problem. It's doing something different. So this one's drawing that. So slightly different. And I'm asking you to put it in order correctly. So you can just look at these pairs of corrected and correct code, and you might have to go back to that example and say, is that import uppercase or lowercase? The import is lowercase, but notice the screen and turtle is uppercase. So it gets you to pay attention to things in that worked example. So I need to import my turtle library, I need to create a screen, need to create a turtle, and then it's usually facing east, so I would have to turn and go right, and there's a right turn 90. Then there's sort of a long side and a short side. So you still have to reason about code, which is, especially now with AI, students are going to be writing less code from scratch, but we still want them to be able to read code, reason about code. So Parsons problems are a great fit for that. And then I'd want to turn left. And if I do something wrong, like I say, go instead of forward, and I check it, rather than get a compiler error, I just get that highlighted, which is pretty clear. If I let go of it, it repairs with the correct, which is also sort of a hint. Hey, do that. If I'm struggling to solve something, so here's a similar problem, I'm going to go ahead and grab some of these and just go right. So do I have everything? Okay. So here's an example of if I have several problems and I'm trying to fix it and I'm struggling maybe a little bit, not quite getting it right. After I've done 3 incorrect solutions, I can use the help button. And if I've used one of these distractors, that's going to animate going back and pairing with the correct, which gives me a hint, hey, use that one. And if I'm still wrong, I can still ask for help. And now it's going to combine blocks, starting with the ones that are furthest apart. At any point, I can choose to solve this myself. I don't have to. So in this one, normally going east, I'd want to go right, forward, and then I'd want to go left. So a mix of adaptive and solving. So that's Parsons Problems. Oops, shoot. Done. I went this little one. Okay. One of the other things that we also created, one of my PhD students, was micro Parsons problems, because sometimes just creating one line of code is difficult for students. And so, for example, with regular expressions or SQL, so we've also created those in the Runestone ebooks. And then one of the things we've also done is our research on Parsons problems shows that most people like them. They find them easier than writing code from scratch. But some people would rather write code than solve the mixed up code problem. And so scaffolding should fade as you develop expertise. So we have that ability. There's this toggle questions that if I show you a mixed up code problem and you're like, I'd rather write the code, you can just toggle to the equivalent write code problem and solve that instead. And we'll grade whichever one you leave in the book. And then conversely, if we've asked you to write code and you're struggling, you can asked to see the equivalent mixed up code problem, but with distractors, and you can solve that. You'd still have to retype the code on the left. But one problem with this block-based feedback that I showed you on mixed up code problems is that there's only one way then you have to just find one correct solution for it. But of course, there's many ways that you can solve problems. So one of the newest things we're doing is using, if you've written some incorrect code and you ask for help, we go to an LLM, find the closest correct code, and then serve you a personalized Parsons problem based on what you've done to help you. And then we can even pre-place the blocks you have correct, which students do value, finding that they have some things correct. And if you have, we can also use your incorrect code, say you have off by 1 error, as distractors. So this is a new feature we've just added to Runestone ebooks and are testing out. We've done some testing prior to actually adding it to the ebook, but now we're going to test larger scale. And so in general, our research on Parsons problems are that students can solve Parsons problems significantly faster than writing code or fixing code with errors. They get similar learning gains from pre to post. However, not if the solution is uncommon. So that's an interesting, but they can learn new approaches if the solution is not the common solution. Parsons Problems can be used both for practice and for exams. So particularly now with AI, and we're not expecting students to necessarily write as much code from scratch, how do you test their knowledge? They should still be able to read code, understand code. So you can use Parsons Problems instead of having them write code from scratch. The advantage of that is they're much easier and faster to grade too. Uh, and they highly correlate with scores on write code problems as well. Students who don't really have any idea what they're doing still have problems with solving Parsons problems. And then students can learn common algorithms from solving Parsons problems, and students prefer solving personalized Parsons problems to just getting the correct code from GenAI because they still have to think but they don't have to do a huge amount of work. You can also do Parsons problems on paper if you're doing paper exams. So one of the things I'll do is sort of print a version of mine with the blocks and the numbers on it. And then what you should make sure you're doing if you're doing it on paper is tell them to write the labels on the right-hand side. So these 1A, 1B, 2, 3A, 3B, but also as much code as they need to keep track. So if you don't have any place for them to write code, then that becomes high cognitive load for them to keep track. Well, what does that mean? What do these numbers mean? So if you're going to use Parsons Problems and exam, that's what I would do. If you're not doing it live in the ebook, which you can as well. I do all my midterms in the ebook. So POGL, one of the things I've done in the ebooks is create POGL exercises where students work in groups, and one student fills in the answers and shares the answers with others. And the activities expose students to the concepts to be learned. I have students record what they learn in a Padlet, which is an anonymous sort of posting thing that they can do. And I go over any questions from the Padlet, and one student answers the questions for the group. And then the other big thing that I've been researching on is peer instruction. So this is a hard multiple choice question that you stop and ask. So typically in my lectures, I don't do a lot of lecture. I'll have them do group work, POGL sort of exercises. I'll look through any questions they have about the POGL. Then I'll do a shortened lecture that I'll have peer instruction questions in. And so this was created by Eric Mazer. There's a whole bunch of peer instruction questions that have already been created for computer science. We've already added a lot of those to the ebooks. So optionally, you can do a pre-reading before lecture. What's nice about an interactive ebook is I can give them points for doing interactivity things in the ebook so that I can kind of make sure they actually do something in the reading. So you could either ask questions about the reading either before or during lecture or require interaction in an ebook. And then students will answer individually first. So they make a prediction, what they think the answer is, discuss with peers, and vote again. It is one of the things we have great evidence for improving student learning and motivation. So one of the things we've done is add another free tool to Runestone Academy. And we've added hundreds of existing peer instruction questions. And we have a new interface. One of the things during COVID, I tried to do peer instruction on Zoom, and it was awful. Because I had to put people in breakout rooms. So I tried to ask people, who do you normally discuss with? Because we went on Zoom after they'd already started the semester. And I tried to put them in breakout rooms with people they normally discuss with. But some of those people wouldn't show up. So we'd have to collapse the rooms. And if I put people with people they didn't know, they wouldn't talk. So one of the things we wanted to add was a text chat so that we could still do peer instruction easily, even if we were remote. And that's worked pretty darn well. What's also interesting is some of the people in a lecture, even if they're synchronous in the lecture, will not talk to other people, but they will type. So instead of talking, I can assign people to text chat groups. And one of the things we do is assign people to text chat groups so that we maximize the number of groups that have people with different answers. Because if you and I have the same answer, we tend to just go, oh, we both got C, we must be right, even if we're wrong. So by having people in groups with people with different answers, they're more likely to discuss and say, oh, you got A, why did you get A? Oh, you got C, why did you get C? So we actually find more learning gains when we assign people to text chat groups than we do when they just talk to the people around them. And then most recently thing that we're doing is we have in the past, oh, I should have showed this down here. If you had to answer questions after class, so for example, I'll have some students that have excused absences. And so they still want to answer the peer instruction questions, but they're not synchronous with anybody. They don't have anybody to talk to. We would show them a saved text chat if we had one. particularly with somebody who answered the way they did, potentially. But that wasn't very interactive. So what we're doing now is if you're answering the question after lecture, we can use an LLM to chat with you. And in this case, we tried an LLM student who picked an answer, but sometimes the answer was wrong. And it would try to convince people of the wrong answer. And we're like, I don't think that's a great idea. So now we're kind of doing more of an LLM tutor. But we did learn from what do students actually do in the text chat, and they don't use uppercase letters. They talk very informally, very short. So we prompted the LLM to do that. And it doesn't just give away the answer, but does try to get ask students questions to try to lead them a bit toward the correct answer. And so they'll vote once, they'll give a justification for their answer, the LLM will respond, and eventually they can decide to vote again, and they'll get feedback whether they're right or not then. Oops. So in general, research on peer instruction does show it improves student learning motivation in many subjects. We've tested our new tool, free tool, in Runestone at 4 institutions, so Duke University, Virginia Tech, Brea College, and ourselves. Instructors like the student engagement, that students are talking to each other and they get immediate feedback of what students are getting or not. However, most students prefer the verbal chat to text chat with assigned groups. We are trying in the future to come up with virtual verbal rooms where they could talk, but that's some of our future work. But some students prefer the text chat with assigned groups. They see more answers, and they're not embarrassed if they're wrong versus when they're talking with their friends. And one of the newest things we've done is ask students in an end of course survey, how much do you agree or disagree with this statement? I use AI frequently for my homeworks and projects. They all pretty much say yes, they do that. I use AI to answer peer instruction questions and to solve mixed up code problems. And most of them say no to those. So that is one way we're getting them not to just jump to AI. So using an AI system also to answer questions. So we've integrated Study Clues is part of Learning Clues, which is a company that another colleague I have works with me has, and we've integrated into the ebook, the Study Clues, which lets you ask questions. So this is a RAG system that ingests all the instructional material. So it has ingested all of the ebooks, the lecture slides, lecture videos, whatever, and then answer questions based on that. So you can, like, if I'm confused, this is often a question that is one of my POGL questions that they work on in groups, that they often are like, wait a minute, why does this print none? And so they could ask that question and get more of a response here. Right now, this is showing the markdown, but we're fixing that so that it looks better than that. So that's a new thing that we're testing. And here's some of my research papers. I'm going to share the link to these slides so people can see those. So in general, what I think the changes that we need to make for teaching programming, given AI now, is less practice writing codes from scratch. So you can use Parsons Problems for that. You can use these new personalized Parsons Problems. More practice with reading and understanding code. Parsons Problems are good for those. So are multiple choice questions. Explaining code. There is an explain in plain English problem also, where you ask people, here's some code, explain in plain English, and then you run that English description through an LLM to see if it generates the correct code. Debugging code, testing code, breaking things into functions, and then using AI to create the functions. And learning how to use generative AI is something we should give them practice with. And more group work, because they're less likely to just jump to AI when they're discussing with others. And one of the things that's happening is with AI is they're not coming to office hours. They're less likely to talk to instructional staff. And so getting them to talk to each other is important. So one of the things I'm going to point out, just a couple of things, is this is the course I'm teaching. It's more of an intermediate Python course. And there are resources for this. I also created a Coursera course on creative coding based on this. But these are the things I use: more POGL work or group work, peer instruction, scaffolded practice. So the other thing I do in lecture is give them pairs of mixed up code where they can switch to the right code, or right code where they could pop up the Parsons problem, or now personalized Parsons problems. I also have an anonymous place where they can post questions and pictures. a Padlet, and then I use Kahoot quizzes for low stakes, active and social learning. And I allow them to use GenAI for everything except quiz and midterms. They must report how they used it. We ask them to use GenAI to help you learn, not just do your work for you, because you learn nothing if you just have it do your work for you. And we're finding what a lot of the researchers are finding, right, that the top end students are capable of using AI to help them be more productive, but still learn. And the bottom end students are often over reliant on AI and then really do poorly on quizzes or midterms where they can't use AI. Also, I try more open-ended creative assignments to encourage them to not just use AI. So like my second homework is use the turtle graphics, create functions to draw simple shapes like circles, triangles, rectangles, and draw something like an aquarium. This is one of the projects that the GenAI and CS Ed consortium that I was on that group that created those. And so here's the AI result when I gave it to AI. It doesn't even look like a fish. Here's my example with instructions, and then these are what students actually did. So they post on a Padlet. And so if you give them more open-ended creative assignments, they're more likely to actually and be more invested in it and do things. Sorry, quick. So for additional resources, I'm going to end early so we can have questions. I do have a Coursera course based on my intermediate Python programming course. This Raspberry Pi, if you haven't been paying attention to that, they do a really nice series about AI research. And then there's some free books on Runestone. And then the GenAI and CS Ed consortium that I did the workshop on, I was on there was faculty groups that redesigned like the CS1, CS2 to leverage AI. And we included a lot of the things that I've been talking about, Parsons Problems, peer instruction, and group work to try to, as well as open-ended creative assignments for some of the things. And all of that material is freely available as well. So I wanted to leave time for questions. So anybody have any questions?
Thank you very much, Barbara. I don't know if I'm being heard, but
Yeah, I hear you.
okay. Yeah, so we can have questions, I think, from the room. Yeah, I see Gunjan. Unfortunately, the camera in our room isn't quite working right, but
Turn on my camera. Barbara, just one minute, a very interesting presentation. I just wanted to, I also teach programming in first year. So some of the examples you gave were very much things that we try and do in first year, first programming course that we do. How big are your class sizes?
Oh, I have about 200 in the fall, but DoC has like 1,000. So one of the nice things about the Runestone platform is it works well, it scales well.
Okay. And it works with, so even if you're 200 people in a classroom or in a virtual room, these technologies that you have shown us work well with that.
Yep.
Okay, great. Thank you.
Yeah, particularly peer instruction is great with large classes. I find it so much more fun than just lecturing when people are not paying attention. I love the energy when we do peer instruction and I tell them to turn and talk to each other. That's in a large classroom. That's a lot of fun.
okay. All right. Oh, Daniel has a question. Just a minute.
Thanks for the talk. Quick question on the use of your Padlet. Are you having your students evaluate each other, or are your TAs evaluating what they've submitted?
The TAs evaluate them. I do have them, they can comment on the Padlet, like if they like something or whatever, they can leave comments.
So you have an army of TAs to help you?
Oh, it's not a huge army. We have 25, for every 25 students, we have one TA.
No, that sounds excellent. That sounds ideal. You may not have had, one of our challenges that we will have to figure out is we don't have those kinds of resources in terms of personnel. Perhaps there might be opportunities to use AI in ways that can alleviate that problem. But if you have insights on that, I'd be open to hearing.
Yeah, so I do all of my midterms in the platform and it's auto-graded. So which is really handy because we used to have big grading parties to grade the midterms when they were on paper. And we don't have to do that anymore. And I have the ability even I'll often do in my midterms, I'll do some multiple choice questions, some fill in the blanks, some the mixed up code problems, and less now of write code from scratch, but maybe one or two where they've had plenty of practice on that. So all that's auto-graded. The only thing I go back and check is the fill in the blank because I give them partial credit when they do stupid things like misspell stuff or, do something weird. But other than that, everything's auto-graded. Open-ended creative projects are more of a pain to grade. So I understand that being more of a pain, but you could ask them to check the rubric against each other. You could have multiple teams grade each other.
All right. Thanks. I have a follow-up question on the midterms, but colleague has a question, says, what's the ratio of top-end students that pass versus the midterms versus the low-end students?
Oh, that's a good question. My course is a required course, so I try to make sure that people can pass it if they're putting in the effort. They may not get an A, which they're annoyed with because they all prefer an A. But I would say that most people get an A. But I also get B's, C's, D's, E's, F's as well.
Okay. All right. Well, thanks. I know in your presentation you talked about students using Parsons Problems in the ebook.
Yep.
How do you proctor those?
Well, the ebook, sorry, the midterms, we proctor, we walk around, they take it in lecture, and we walk around and make sure that they're on that page and not, going off to AI doing stuff. And it doesn't allow paste, which also helps. When you're taking an exam, you can't paste something. So even if you got over to AI and tried to type stuff in, it would be hard. You can't paste it. You'd have to retype everything, which would take time. But
Okay.
yeah.
Okay, no control V. All right. There are two questions in the room. Just a minute.
Thank you. Name is Carl Beckford. This is a quick one. So we like the idea of the coding where it's in blocks and they can move around the blocks. And because those are maybe just like images, because we found that when we use images for our multiple choice exam, we believe it might have lessened the person's just dropping the question in some tool. But we also found that the quote unquote bad students, I don't know if that's quote unquote, would literally therefore spend the time and type up what they see in the image in something and then ask it to then solve the problem. I'm wondering, in the case where we're blocking the code, if those students choose to still be bad, if there are ways to get around it or really trying to help them to help themselves?
Well, so my exams are time limited. They don't have a lot of time. So they probably isn't a great approach would be to type everything in because that would take you too long and you wouldn't answer other questions. So that's one way I deal with that is, you wouldn't have time to type all that in. Another is the mix-up code problems are not pictures because for accessibility, you still want that screen readers to work with that. In fact, Dan Zingaro, if you're familiar with him, is at University of Toronto and he's blind and he tested it for me and he said that actually works pretty well for blind students.
Okay. Thanks.
Hi, Barbara. Thank you very much for the talk. Question. So I know Daniel asked earlier about the pass rates and so forth, but how would you say the pass rates compare with those prior to AI or pre-AI? How is it that the pass rates have gone up? Have they remained the same? Have they dropped? What would be your comparison there?
I would say pass rates in general have remained similar, but grades have dropped. That the students, I guess I say that the bottom end students are over-reliant on AI and tend to use it and not learn as much as they used to. And so they're doing worse on midterms. I don't have an exam. I have a final project instead, and it's an open-ended final project. And I'm, because this is a required course, and I'm in a school of information, and we basically have two pathways. There's sort of data analysis pathway, and there's UX. And a lot of the UX people don't think they ever need to learn to program. And so they have to take my course, they have to pass it, but they don't really want to learn to program. So one of the difficulties about my course is I get School of Information students who have to pass it. I get other people from other majors who have to pass it. And I also get a lot of CS students who take it because we teach Python, and in CS they only do C++. And they would like Python on their resume. They also like that we do more open-ended creative projects because unfortunately our CS department does not do that. So they really value that, oh, we give them this open-ended. The final project is grab data from APIs, store it using SQL or SQL in a database over time. So not, recreate it constantly, store it over time. And then once you have all the data in your database, do a join, do a select and a join with the data using SQL, and then calculate something, write out a report, CSV file or some other file, and then create plots with matplotlib. And so that's a full project that they really enjoy. They can do whatever they want. So whatever API they want to work with. So we get basketball and COVID and stocks and, all sorts of different things that they do.
All right. Thanks. Dr. Mervyn Chisholm is with the Center for Excellence in Teaching and Learning, and he has his hand raised, so I'll let him speak.
Thank you, Daniel. Barbara, thank you for your discussion, for your lecture. I'm from a teaching and learning background, and certainly I have no knowledge of computer science. So I struggle to follow some of the things you're saying, but I was quite interested in what you were saying about interactive lecture. But you call it peer instruction, though, which I would have thought it was a kind of interactive lecture. And I just wondered, why did you consider that peer instruction, since the peers were engaged, but it was more like a very small amount of engagement with peers?
Yeah, so Eric Mazer at Harvard is the one who coined that term, peer instruction. And it is a bit confusing because people also think it just means learning from peers, which is not what it means. It's this very prescribed thing. Ask a hard multiple choice question. The goal is 30 to 70% of the people get it correct on that first vote, and then have them discuss with peers, and then have them vote again. And so that's his name for this very specific instructional thing.
Okay, I think in other places they talk about it as being interactive, instruction,
Sure.
lecture, an interactive lecture.
And some people
Okay.
would just say it's think, pair, share, right?
Right. Okay, thank you for that explanation.
Yeah, it's not a new idea. One of the things I love about lecture when you do that is hearing people go, oh, because they didn't see something originally, and then they talk to the people around them and they suddenly see. I'm like, yes, learning has occurred. Yay!
Yeah. Thanks, Barbara. There was a question, is Runestone free?
Yep.
Someone asked.
Yep.
Okay.
All our books are free, everything's free, and we're dedicated to keeping it free.
Yeah. Okay. All right. That's useful. Another person, this is offline in a chat. Someone is wondering if the grade distribution might be different if students had to take a written exam. Do you have any data on that or any thoughts?
No, I haven't done paper. I used to do paper exams. Like I said, we used to have a grading party then with everybody, the instructional staff, all grading that night. So that took us several hours to grade. And once we moved to online, I'd rather do it online, particularly, it's just we don't have to spend hours doing it. They get immediately as soon as they finish. So I do what's called a timed exam in the ebook, and they don't get any feedback. Because often also what I have is some people taking it the day that they're supposed to, but then there's always people that are sick or out of town or whatever. So I don't want people to know what they've gotten right or wrong. So they don't get feedback after they finish, but they do see their score on the top right. So they immediately know what they've gotten. Now, of course, that score may go up if I look over their free response parts to see if they get partial credit at all, but that they immediately know what they've done. They don't know what they got right or wrong yet. And then after everybody's taken the exam, I show it to them live in lecture so that they can look at what they got wrong. and then I turn it back off again because I reuse those exams from semester to semester.
Thanks for that. I have another follow-up question. Since so much of the work is online, are there any assessments where your students are taking those asynchronously? I mean, you just gave an example where it might be an exception. Somebody got ill, there's a good excuse why they're not taking it with everybody else. But if there are particular assessments that are asynchronous, then one of the things that we have to deal with is students sharing what they had to do and therefore giving an unfair advantage to others.
Yeah.
The way that I've tried to address that is to create bigger banks of problems, and then that requires tools to do that. And of course, there's an issue of balance and you know, equity across the questions that you ask. You think you're asking the same question in different ways to different students. You have to make sure that that actually is testing the same things. And there's all kinds of interesting challenges there. I wondered if you have had to face any of that, and if so, how you've dealt with it. Has AI come into that in any way?
I haven't. I mean, I certainly have dealt with this, right? I have people that'll be taking the exam several days after everybody else has taken it. What I do is go over those. I give them the ability to take them on their own remotely. I also do have the same thing with people with accommodations. So we have people that have like 1.25 time, 1.5 time, 2.0 time, 2.5 time, 3.0 time. And I used to handle that with, you know, me having to proctor that group in a separate room because they also have limited distractions and a bunch of other things. And I eventually went, okay, this is crazy. I'm just going to let them do it remotely. But I'm going to go back and look at those with finer detail, because one of the nice things in Runestone is I can see everybody's answers. I can go to a particular student and say, show me all their answers to every question. And I can look for, is there anything that looks suspicious here? You know, I can and have at the past done two different versions, you know, since I have in the fall, I teach two sections. So I'll have one section taking it, you know, Wednesday and one section taking it Thursday. So I have tried to create, if not equivalent exams, I'll sometimes just change the order of the questions. So they can't sort of be like, you know, the answer to one was A, you know, the answer to two is B or something, right? I don't know if they could remember that anyway. We make them put their phones away, we make the proctor. But if they had any idea of that, then we would try to create different versions.
All right.
Hi, Barbara. I wondered for the proctored exams, are you using a lab or are the students using their own devices?
They're using their own devices. It's in lecture during lecture time, which is part of why I have the accommodations people do it elsewhere, do it on their own, because they, you know, just got to be so many of them and such a hassle to give them 3 times time or 2 times time.
Hi, Barbara. Question again. So you just said about having questions and probably question banks and so forth. But then how do you, what structure of questions do you have? Is it fully multiple choice? Do you have like short answer? Because what we've discovered with, like, if you try to do an online exam with longer questions, and well, with longer questions, you give like 5 longer questions in 2 hours, let's say, then it enables the ability for them to go off, check using AI, get an answer, and copy and paste back in. So how do you structure your questions to get around that problem?
Yeah, just a second. I can show you one of my exams. Give me a second here. Yeah, so I usually have multiple choice questions. I used to be on the Advanced Placement Computer Science A Development Committee, and that exam is half multiple choice questions and half write code on paper that everybody has to grade. And we used to go and spend a week grading these tens of thousands of exams on paper, which was entertaining to try to read all that stuff. But what I do, let me share here again. This is the instructor interface for that. So there's lots of assignments. This would be M1, midterm 1, fall 25. So, and I give them practice exams too, because I find that they panic. You know, they're always worried about what the questions are until I give them a practice exam. And then I give them a practice midterm first. So let me get to the actual one timed 25 p.m. practice. I'm trying to find the actual one. F25. Okay, here we are. Accommodations. So when they have a timed exam, this is what they see when they start it, and it's going to count down. So they have 80 minutes unless they have accommodations. And they'll see one question at a time. So this is multiple choice question. They can answer anything. I'm just going to click A. They can also flag a question if they're not sure about the answer and want to go back to it later. And that'll highlight this in orange so that they remember they want to go back to that later. And there's some that are choose all that applies. So self-name, color brown. Okay, so you can just say what all the things are that you could do. Yeah, okay. And you'll see I'm getting no feedback on them. So I'm not getting told whether I'm right or wrong. So I can go through and do all of these. So there's, I think, around 15 multiple choice questions. Yeah, then there's some fill in the blank questions. A function that's defined in a class is called a method. Yeah, these are all things that they've learned in lecture. What's an attribute of this object? So you can type in, so these are type in answers, they're complicated, conditional. This is my first midterm. And then there's the mixed up code problems. And they, again, don't get any feedback. They drag things over. Rectangle class, let's see, class rectangle. So they would drag stuff over, they would indent it, but they're not going to get any feedback. And
The indentation.
oops. And then there's a couple of write code questions. And these are things that they've practiced already, they've seen in the past, maybe slightly modified. And they can write the code. D equals 4, 4 key comma value in d times. I have to stop and think a little bit because I've just been working on Java, so my brain is if value is less than cutoff, out D of key equals value, return out D. They can run it, they can see compared to these prints, but they're not seeing the hidden unit tests. So I encourage them to add other print statements if there's more complicated things, like there might be a conditional that they have to do. I think maybe this one. Yeah, so here's a more complicated conditional. So there's only a couple of test cases here that they should check, but they should check all of them. So yeah, this is my midterm. And once they've seen every question, which I have not yet, there'll be a button to say finish the exam, because if I showed them that too early, they would just click on it after they answered one question. Where is the one I haven't seen? There it is. So once they've seen every question, the finish exam shows up. And then when they click on that, it asks, are you sure you really want to submit your exam and be done? If they ran out of time, it would save all their answers. So that's not a problem. I always remind them that when they're getting down to the last few minutes, don't worry, everything's going to be saved. You don't have to hit this finish exam button. But once they finish it, they're getting no feedback other than their score. And they can refresh to see their score. But, and this is probably a score where I had done this before because I didn't finish doing all of them, but it's taking I have done this multiple times. So that's a timed exam in the ebook.
Sorry, Barbara, what you were showing us just now, have you used any of the Moodle platforms? Are they similar to what Runestone? I'm not sure what the Runestone is. Is that similar to that, or?
I haven't used Moodle, but a lot of these other platforms don't have all these capability. They don't have like mixed up code problems. So like Canvas is what we use. But you can do multiple choice questions. I'm not sure if you can run code in Canvas, but so we have more capability.
Okay. Thank you.
To run code, but it hasn't been enabled by our information technology services team for whatever reason. So, all right. Are there any other questions? But I want to thank you very much. I don't see any from online. I don't see any hands. So I want to thank you, Barbara, for coming and talking with us. I know it's near the summer, and I think
It is summer. Yay!
It is summer. There you go. and so people's availability is quite limited. So I want to thank you for taking the time to meet with us. We still have to tie up.
Sure. Thank you for inviting me. And I will send you the link so that you can send it out if you want to.
Okay. All right. Thank you very much. I think
And I'm happy to answer other questions if people want to talk.
Right.
Thanks. Bye, everybody.
Yeah. So thanks and have a good summer. All right. So thank you, colleagues, for joining. And so let me stop the recording. Give me a minute.